Solution TV, learning made easy, come and see. Chemistry, math, Kiswahili. We like the spark to Nawasha Akili. Online Solution TV, from Bome to the world we teach free. Click, watch, grow, no mystery. With the future ni sisi tayari.
Chemistry definitions and the laws you must be familiar with. Drugs and drug abuse. A drug is a substance, natural or manufactured, which when used alters the way the body functions. Drug abuse. The use of a drug for a purpose other than what it is meant for is called drug abuse, or you can say use of overdose or underdose of a prescribed drug. A laboratory. A laboratory is a building of a special room where chemicals and apparatus are kept and in which practical subjects such as chemistry are studied. Sublimation is a process by which a substance changes from a solid state to a gas state when heated. State the kinetic theory of matter. The kinetic theory of matter states that matter is made up of particles which are in a continuous state of motion. An element is a pure substance which cannot be split into simpler substances by chemical means. Compounds. A compound is a pure substance made up of two or more elements which are chemically combined. An atom is the smallest particle of an element that can take part in a chemical reaction. An indicator. Indicators is a substance which shows different colors when in acidic solution or basic solution. Rusting is the corrosion of an ion due to its reaction with atmospheric oxygen and moisture. Atomic number and mass number. Atomic number is the number of protons in the nucleus of an atom. Mass number is the sum of the protons and the neutrons in an atom of an element. Isotopes are atoms of the same element having the same atomic number but different mass numbers. Valence, the number of electrons an atom loses or gains during a chemical reaction, is the valency of an atom. Valency is also called combining power of an element. Radicals. Radicals are groups of atoms with a net charge that exist and react as a unit during chemical reactions. For example, the sulfate ion, carbonate ion, the hydroxide ion, ammonium ion, all those are called radicals. The nitrate, all of those are radicals. Alkali metals, these are group 1 elements of the periodic table. Ionization energy, it is the energy, the minimum energy required to remove an electron from the outermost energy level of an atom in its gaseous state. Alkaline earth metals, the elements in group 2 of the periodic table are called alkaline earth metals. A ductile substance, these are materials in one which can be drawn into a wire. A malleable substance, materials which can be hammered into sheets and are said to be malleable. Brittle substance. A brittle substance is one which is hard and likely to break, like a chalk. structure is brittle. Halogens are nonmetals in group 7 of the periodic table. Example, bromine, fluorine, chlorine, bromine, and iodine. Noble gases, these are elements in group 8 of the periodic table. They are also called noble gases. Ionic bond, also called electrovalent bond, is an ionic bond is the electrostatic force of attraction between a metal and an nonmetal. An ionic bond is formed when there is a complete transfer of valence electrons from one atom to another, resulting in two ions with opposite charges, which mutually attract one another. The resulting compound is called an ionic compound. Covalent bond is a bond that is formed when nonmetals combine. So it is covalent bond when it's a bond formed when atoms share a pair of electrons between them, each donating an electron to be shared. Covalent bonding occurs when between atoms of nonmetals. A coordinate bond is a type of a covalent bond in which the shared pair of electrons forming the bond are contributed by only one species. Examples of substances which undergoes covalent bond, dative bonding or coordinate is ammonium ion, carbon 2 oxide, hydroxonium ion, ozone layer, which is O3, aluminium chloride, dimer, that is this one, and nitric 5 acid also undergoes that. A salt is a substance that is formed when the hydrogen ion in the acid are wholly or partially replaced by a positive ion. Types of salts, we have normal salt. This is a salt that does not contain any replaceable hydrogen atom. For example, sodium chloride, sodium carbonate, potassium sulfate, calcium nitrate. These are called normal salts. These salts are neutral in aqueous state. They are neutral in aqueous state. They are not acidic, they are not basic, therefore they are neutral. Acid salts. These are salts. Acid salts are salts that contain a replaceable hydrogen atom. Some examples are sodium hydrogen carbonate. This one is an acid salt. Potassium hydrogen sulfate, this one, and sodium dihydrogen phosphate. They have acidic properties due to the presence of a replaceable hydrogen. Basic salts. For example, these are salts. Basic salts are salts that basic salts are salts that contain hydroxyl ions. It is the presence of hydroxyl ions in these salts that is responsible for the basicity properties. Examples of these are magnesium chloride, basic magnesium chloride, basic lead 2 carbonate, basic zinc chloride. These ones are basic. They contain hydroxyl ions, which is responsible for the basicity. Double salts. Double salts are salts in which there are two different anions and cations. Examples are hydrated potassium aluminium sulfate, this one. hydrated ammonium ion 2 sulfate, this one, trona, this one. These are called double salts. Deliquescent substance. A deliquescent substance, these are salts that absorb water. You can say these are salts or this is a substance. These are substances. A deliquescent substance, these are substances which absorb water from the atmosphere and form solutions. For example, we have anhydrous calcium chloride. Actually, anhydrous calcium chloride is used as a drying agent because it absorbs atmospheric moisture. So sodium hydroxide is another deliquescent substance. Calcium chloride is another deliquescent substance. Iron 2 chloride, potassium hydroxide and zinc chloride, all of those are deliquescent. So what is deliquescency? Deliquescency is the process by which substances or salts absorb water from the atmosphere and form solutions. It is important to finish that if they form solutions. If you don't do that, you might be talking about hygroscopic salts or substances. So let's look at hygroscopic. Hygroscopic substances or salts are salts that absorb water from the atmosphere, yes, but do not form solutions. They don't form. Example is anhydrous copper 2 sulfate, anhydrous copper 2 chloride, potassium nitrate, and common table salt, sodium chloride. Therefore, hygroscopy is the process by which salts absorb water from the atmosphere, but they do not form a solution. They don't form a solution. Efflorescent salts are salts which lose water from the water of crystallization when exposed to the atmosphere. This one, they lose their water to the atmosphere. Example is sodium carbonate dehydrate. Efflorescence is the process by which salts lose some of their water of crystallization when exposed to the atmosphere. Conductors. A conductor is a substance which allows an electric current to pass through them. Non-conductors is the opposite. Substances which do not allow an electric current to pass through them. Electrolysis is the process of decomposing an electrolyte by passing electric current through them. An electrolyte is a substance which, when melted or dissolved in water, conducts an electric current and gets decomposed by that current. So electrolysis is the process of decomposing an electrolyte by passing an electric current through it. A binary electrolyte is one which contains only one type of a cation and one type of anion. A binary electrolyte is one which contains one type of a cation and one type of anion. An allotrope is an element which exists in an allotrope is an element which exists in more than one form in the same physical state. Example is diamond and carbon. Allotropy then is the existence of an element in more than one form in the same physical state. State Boyle's law. Boyle's law states that the volume of a given mass of a gas is directly proportional to its pressure at constant temperature. Charles' law states that the volume of a given mass of a gas is directly proportional to its absolute temperature, its pressure kept constant. Diffusion gas laws that is Graham's law, says that diffusion is the process by which, now we are defining diffusion first. Diffusion is the process by which particles spread out from a region of high concentration to a region of low concentration. Graham's law of diffusion. Graham's law of diffusion states that the rate of diffusion of a gas is inversely proportional to the square root of its density under the same conditions of temperature and pressure. Graham's law states that under the same conditions of temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its density. So this is that's how it states. Or you can say Graham's law states that provided temperature and pressure are constant, the rate of diffusion of a gas is inversely proportional to the square root of its density. Molar solution. A molar solution is a solution that contains 1 mole of a solute in a liter. Molarity of a solution. It is the number of moles in 1 liter. The number of moles in a liter is called molarity, or mostly when you write capital M to capital M, it means molarity, number of moles in a liter. Endpoint, it is the point at which the reaction is complete. For example, when sodium hydroxide is reacting with HCl, when the color of the indicator changes, that is called the endpoint. Atomicity is the number of atoms in 1 molecule of an element. State. Avogadro's law states that equal volumes of gases will contain equal number of molecules. Gay-Lussac's law states that when gases react, they do so in volumes that bear a simple ratio to one another and to the volume of the product if gaseous temperature. Gay-Lussac law Gay-Lussac's law states that when gases react, they do so in volumes that bear a simple ratio to one another, and the volumes of the products if gaseous temperature and the pressure remaining constant. Isomerism is a situation whereby 2 or more compounds have similar molecular formula but a different structural formula. That one is called isomerism. Such compounds are said to be isomers, or are called isomers. So isomers are compounds that have the same molecular formula but a different structural formula. Dehydrating agent is a substance which is capable of removing chemically combined water or the elements of water from a compound. Dehydration, therefore, is the process of removing water or its elements from a compound. Scrapping by sulfur oxide is the process of scrapping the sulfur oxide is the process of passing the exhaust gases through chimneys lined with calcium hydroxide to reduce the amount of sulfur oxide released to the atmosphere. Acids. An acid is a substance that dissociates in water to give hydrogen ions as the only positively charged ions. A strong acid is one that dissociates completely and yields main hydrogen ions in aqueous solution. A weak acid dissociates partially and yields few hydrogen ions in aqueous solution. A base is a substance that dissociates in water to produce hydroxide ions as the only negatively charged ions. Strength of a base. A strong base is one that ionizes completely in water to produce hydroxide ions. Weak bases partially ionizes to form hydroxide ions. The metal oxides and hydroxides which react with both bases and acids are said to be amphoteric. Example, we have zinc, aluminium, and lead oxides. They are amphoteric. Solubility. The solubility of a solute in a solvent is the maximum mass of a solute required to saturate 100 grams of the solvent at a particular temperature. Fractional crystallization. This is the separation of different salts by making use of the differences in their solubility in the same solvent. Enthalpy of solution. The enthalpy change that occurs when a substance is dissolved in a solvent to give an infinite dilute solution. But molar heat of solution. It is the enthalpy change that occurs when 1 mole of a substance is dissolved in a solvent to give a dilute solution. Enthalpy of combustion is the enthalpy change that occurs when a substance burns completely in oxygen. But molar heat of combustion is the enthalpy change that occurs when 1 mole of a substance is completely burned in oxygen. So you can see the difference between molar heat of combustion and the other. Enthalpy of displacement. The enthalpy of displacement is the enthalpy change that occurs when a substance is displaced from a solution of its ions. But the molar heat of combustion now is the enthalpy change that occurs when 1 mole of a substance is displaced from its solution, from a solution of its ions. So you can note the differences when we talk about enthalpy of displacement and the molar heat of displacement. Enthalpy of neutralization. The enthalpy of neutralization is the enthalpy change that occurs when an acid and a base react to form water and salt. Then the molar heat of neutralization now is the enthalpy change that occurs when an acid and a base react to produce 1 mole of water. Hess law. Hess law states that the energy change in converting reactants to products is the same regardless of the route by which the chemical change occurs. Hydration energy is the energy change that occurs when 1 mole of gaseous ions Hydration energy is the energy change that occurs when 1 mole of a gaseous ions become hydrated. Regitalis principle. When change in conditions is applied to a system in equilibrium, the system moves so as to oppose that change. Radioactivity. Radioactivity is the process when an unstable nuclide breaks up to yield another nuclide of different composition with emission of the particle and energy. A half-life. The half-life is the time taken for a given mass of a nuclide to decay to a half its original mass. That is the key word. The period, the time taken for a nuclide to decay to a half the original mass is called that, a half-life. Assalamu alaikum mahali popote ulipo, Mwalimu Nyachio here. I want to take you through Chemistry Paper 1 expectation. Unfortunately, Chemistry Paper 1, it is not very easy for you to say this part is going to come. You are supposed to read from page 1, Form 1, Introduction to the radioactivity, the last question. That is the unfortunate part of it. But one thing I am sure is that from Form 1 to Form 4, we have around 18 gases. And the preparation of a gas and the properties of a gas must be there in Form 1. And that is why I'm going to take you through 18 gases in Form 1 to Form 4, which you are supposed to know how they are being prepared, how they are being collected, and their properties. Welcome. Share to the rest. Welcome. Gas number 1, Form 1, oxygen. So here I want you to know the reagents used, the method of gas correction, and the uses of that gas. So oxygen is prepared in the lab by a reaction between hydrogen peroxide and manganese. Actually, this is not a reaction. Manganese peroxide here is used as a catalyst. So hydrogen peroxide will decompose to form hydrogen gas and water, and it is important you know how to write an equation. So hydrogen peroxide is written like this. Will decompose in the presence of manganese for oxide as a catalyst to form water and oxygen. So this is the reaction which you need to balance like this. And this is an aqueous, and this is water liquid, and this is a gas. And that is what we need. Now the gas is corrected over water method. The method here is over water method. Why is it collected in this method? Because higher oxygen is almost insoluble in water or slightly soluble in water. Oxygen is slightly soluble in water, therefore collected in this method. This is now the equation, the word equation in Form 1, but I have written the chemical equation for that. We can as well use sodium peroxide and water. We will use the same, this one, but this time around we will put water here, and inside here we will have sodium peroxide. Whenever you see here we have sodium peroxide, and Na2O2. Sodium peroxide, we must have water here. So this one also will give us the oxygen, and you should know how to write the reaction with this water and the sodium peroxide. Let me write the equation for you if it is sodium reacting with sodium peroxide, this one here. Then the equation should be sodium peroxide reacting with water to form sodium hydroxide plus oxygen. Very important for you to note. And then now you need to balance the equation. You can put it 2 here and put 4 there. So this is 2, 4, this is 8. This is good. Is it balanced? We need 2 here. Yeah, we need 2 here. And that is now okay. 2 plus 6. Very good. So this is a gas. This is aqueous, liquid, aqueous. So this is the equation for this reaction here. Now, uses of oxygen. I have 2, 3 uses of oxygen. Only 2 is okay. Industrial use and any other use. So you must have this, at least 2 uses of oxygen. And then the test for oxygen. How do we test oxygen? When you introduce a growing sprint, ile inakaa kama kijiti yenye kuna moto hapa mbele. Ukiweka hivi inawaka, inaitwa rewriting or rekindles. So oxygen rekindles or rewrites a growing sprint. This is the test for oxygen. So So ukijua hiyo maneno nimemention hapo, so ukileta oxygen you will get everything. In paper 1 there must be one gas being prepared from form 1 to form 4. IES Peter Bure. Number 2, hydrogen. Number 2, hydrogen. How is hydrogen prepared in the lab? We prepare hydrogen in the lab by the reaction of zinc granules with hydrochloric acid, as you can see from the diagram. Now, hydrogen gas is collected over water, or it can as well be collected by upward delivery. This here, upward delivery. This one is called downward displacement of air or upward delivery. So, if it is hydrogen, remember, it is collected in two ways. Mostly, we want hydrogen which is dry, so we always use. So we have said hydrogen is collected in two ways. I have explained now. The next thing you need to know is the reason why hydrogen is collected by upward delivery. Hydrogen is collected by higher upward delivery because hydrogen is lighter than air, or it is less dense, or it is lighter than the air, That's why it is collected by upward delivery. It is less dense, you can see here, less dense. Another thing you need to know is how dry hydrogen is prepared. Dry hydrogen is passed through anhydrous calcium chloride. So anhydrous calcium chloride is used as a drying agent, or you can use concentrated sulfuric acid to dry the gas and then collect it by upward delivery. So this is important for you to note. Now the next thing is to know how to write the equation. This is a zinc, which you are going to add HCl, then it's going to give you zinc chloride plus hydrogen gas. Put it to here and put the status, and you are done how to write the equations. This is a gas. Very important. I think that is now no uses of hydrogen, at least 2 uses. How is hydrogen tested? It is important to know that hydrogen is tested. You introduce a burning sprint. A burning sprint is the one which contains a flame. When you introduce it to the mouth of a test tube containing the gas, you will hear a pop sound. It's called a pop sound. That's how it is tested. Uses of hydrogen, please know at least 2. Just have 2 of the uses if you want not to miss 3 marks for this. In fact, for all of this, we are looking for around 3 or around 5 marks in total. Number 3, now we have finished done in Form 1. Form 2, we start by preparing carbon dioxide. These are the reagents. Carbon dioxide is prepared by dilute hydrochloric acid with calcium carbonate. So there is sodium hydrogen carbonate here, and there is conch sulfuric acid. Now these are the things which you need to know. And then the most important, you should know that carbon dioxide is collected by downward delivery. Let's try to answer these questions very fast. I see time is running out. What is observed in the conical flask when dilute hydrochloric acid is added to this? There is a vigorous effervescence because this is a carbonate. Effervescence occurs. Write the equation for the reaction taking place. This is the equation which you must know how to write. Explain the purpose of sodium hydrogen carbonate in the setup. What is the purpose of this sodium hydrogen carbonate? The purpose is to remove traces of hydrochloric acid fumes in the gas. So if the fumes of hydrochloric acid gas is available, it's going to react with sodium hydrogen carbonate hence removed. Explain why the gas is passed through concentrated sulfuric acid. It is to dry the gas. Therefore, conc sulfuric acid acts as a drying agent. Suggest the alternative of concentration. Instead of concentrated sulfuric acid, which other drying agent can you use? You can use anhydrous calcium chloride. Very important. This one is saying chemistry is not easy as you think. No, it is much easier than that. And that is very, very critical. This is called Mr. Kimtai. He says chemistry is not easy as you think. No, it is much easier than you think. It is much easier than you think. I love that. Properties of carbon dioxide. It is important you know that. Explain why carbon dioxide is collected by a downward delivery. It is because it is denser than air. It is denser than air. Those are the things you need to know. What deductions can be made about the properties of carbon dioxide gas from the following tests? When you bubble the gas through water containing a universal indicator, the carbon dioxide is acidic, therefore the blue litmus paper will change to red. If it is an indicator, the solution will be red. That is very correct. So carbon dioxide is an acidic gas. Separate geocarbon dioxide through water and sodium hydrogen carbonate. Carbon dioxide gas slightly dissolved in water to form carbonic acid, weak acid, this one. Carbon dioxide gas is an acid, is acidic and reacts with sodium hydroxide solution to form sodium carbonate. And this is it. Very nice. I don't want to. Another thing about carbon dioxide. Carbon dioxide does not support combustion. Therefore, if you invert carbon dioxide under this one is going to stop burning, it will go off because it does not support burning. It is actually used as a fire extinguisher, as we shall see towards the end. How do we test for carbon dioxide? You pass carbon dioxide gas in lime water. Through lime water, lime water is called, you pass it through lime water. Lime water is calcium hydroxide actually. And the calcium hydroxide, which is a colorless solution, will change to a white precipitate, indicating that the gas is carbon dioxide. So the reaction between lime is called calcium hydroxide. So explain using equation the change, okay. Bubbled through, when carbon dioxide is bubbled through calcium hydroxide for a short while, a white precipitate is formed. That one is a test for carbon dioxide. Chemical properties of carbon dioxide. Magnesium burns in carbon dioxide. Despite the fact we said that carbon dioxide does not support combustion, but when a burning magnesium is introduced into a gas containing carbon dioxide, it will continue to burn. Do you know why? It is because magnesium produces a lot of heat, which decomposes carbon dioxide into oxygen and carbon 2. Therefore, the oxygen produced makes the magnesium to continue burning. The magnesium produces a lot of heat that decomposes carbon dioxide to carbon and oxygen. Now, this oxygen is the one that supports the magnesium to continue burning, and this is the reaction which will take place. Carbon dioxide, we are in gas number 3, and I see it has so much information here. Uses of carbon dioxide. Carbon dioxide is used as a refrigerating agent. It is also used as fire extinguisher because it is non-flammable and it is denser than air. It is also used in the manufacture of sodium carbonate in the solvay process. Remember that. So uses of carbon dioxide. Make you take me now the second gas in form 2 is carbon 2 oxide. How is it prepared? It is prepared when concentrated sulfuric acid react with methanoic acid. Those are the reagents in the laboratory preparation. Remember that. And then it is collected over water. So if it is collected over water, then it is slightly soluble in water. You can as well use conjugated sulfuric acid and ethanoic. Ethanoic, this is O, acid. Ethanoic acid will react to form carbon 2 and carbon 4. Properties of carbon 2. Carbon 2 oxide is a reducing agent. Carbon 2 oxide is a reducing agent. Carbon 4 oxide reacts with carbon to form carbon 2 oxide. We are not talking about the gaseous mixture should be okay. So carbon 4 oxide plus this one, charcoal, it forms that. That's another way of preparing carbon 2. Form 3, the first gas prepared there is the ones for organic 1, but Mr. Kimutai skipped to nitrogen. We will go back there, down there. So nitrogen is the fifth nitrogen. How is nitrogen prepared? You heat ammonium chloride with sodium nitrite, and it forms nitrogen gas collected by upward delivery. You should be able to know how to write this equation. Ammonium nitrate is unstable and decomposes to form nitrogen and steam. So these are the things you need to understand if at all you needed to get marks in paper 1. Paper 1 is very tricky because you do not know where the questions are set from. Questions are set from form 1 to form 4. So you need to read between the lines. That is the unfortunate thing with chemistry paper 1. Nitrogen 1 oxide is prepared by heating ammonium nitrate in a round bottomed flask. The gas is collected by over water method and the water should be warm. The water should be warm. Why is water needed to be warm? It is fairly soluble in cold water, but insoluble in warm water. So if you collect in cold water, it will dissolve in that water. But in warm water, it is almost insoluble. Uses of nitrogen 1, please master 2 or 1. Nitrogen 4 oxide, what are the reagents used to prepare that? Dilute nitric acid, copper 2 tannings. How is the gas collected? Nitrogen 2 oxide, it is collected by upward delivery. This one is supposed to be 2. It is collected by upward delivery. And this is the equation which takes place. Another gas is nitrogen 4 oxide. How is nitrogen 4 oxide? It is the reaction between conc nitric acid and the copper tannings gives us nitrogen 4 oxide, and you can see it is collected by downward delivery. It means it is denser than air. Another gas is ammonia gas. How is ammonia gas prepared in the lab? You heat gently a mixture of calcium hydroxide and ammonium chloride. And this is how the gas is collected by upward delivery, meaning it is lighter than, it is less dense than air. And these are the equations which you need to know how they are written. So this is on the left side, and on the right side, this plus this plus this. So it is important you know the reagents. Uses of ammonia, at least know 2 uses. Sulfur oxide, we are now in sulfur and its compound. You should know how sulfur oxide is prepared in the lab. Diluted hydrochloric acid reacting with sodium sulfite, and then it is collected by downward delivery. Sulfur 4, the reagents. So just to go through, that is form 3, the topic is sulfur and its compound. Go through that gas. The next, like number 11, is sulfur oxide, how it is prepared and some of its properties. Uses of sulfur oxide. Hydrogen sulfide, very important for you to know how this one is prepared. Diluted hydrochloric acid with iron 2 sulfide, those are the reagents. Method of gas collection, hydrogen sulfide is collected by over water method. Then you should be able to know to write this equation. If you want it dry, you pass it through anhydrous calcium chloride. You cannot use concentrated sulfuric acid in this case to dry this gas, because this gas would oxidize the sulfur to sulfur. It would oxidize the corn sulfuric acid will oxidize this one to sulfur. Chlorine, how is chlorine prepared in the lab? Then look at the reagents. So I'm trying to show you the things you need to go as you revise. You need to go through hydrogen chloride, how is it prepared, rock salt, method of gas collection. Methane, the organic, methane, how is ethane prepared? Ethene. Ethine. So in form 4, there is no gas collected there and prepared.